Hello everyone, today we're going to go ahead and learn about evaluating trig functions with given reference angles, or we will find the reference angles. So let's go ahead and begin by starting on this quick do now. This is very similar to what we learned yesterday. And just to go ahead and refer back to our notes, go ahead and pause the video and give this a try. So the first thing that I want you to go ahead and recall is that we are using this right here. All students take calculus. So we're going to go ahead and see that we have tangent of some angle is going to give us 3/4. Okay. For this right here, we see that 3/4 is positive. We're going to go ahead and see that tangent is positive in which quadrant. So let's go ahead and look at this. A means all, everything is positive. S means sine, its reciprocal are positive. Everything else negative. And here we see that tangent is positive and its reciprocal cotangent are positive, and C only cosine and secant are positive. So in this case, we only have tangent being positive in quadrant 1 and in quadrant, where is it? Quadrant 3. For the second part of this, the second condition says that cosine is less than 0. So cosine is negative. So we're going to go ahead and see that cosine is negative wherever it is not positive. So we know cosine is positive here, right? Where everything is positive, and here everything is positive for cosine. We don't want that. We want where it is negative. So therefore only quadrant 2, right, and quadrant 3 will be the possibility. So no, we know that quadrant 3 is where we're going to go ahead and draw our little triangle here in quadrant 3, right? Quadrant 3, because it was true for tangent and cosine. So let's go ahead and continue. We have this right here. Okay, and remember, your triangle is formed with the x-axis, so keep in mind the little bow tie that I showed you guys. This right here will be your adjacent, the x-axis, your opposite, and your hypotenuse. Okay, so from here we can go ahead and fill in what we know. Tangent, in this case, was 3/4, and we know that tangent is opposite over adjacent. So in this case, we have an opposite length of 4 and an adjacent length of 3. Keep in mind that these right here are going to be negative because of the orientation where they are. So keep in mind, anything to the left of 0 in the horizontal is a negative x. Anything below the x-axis, where y equals 0, we have negative heights as well. So we have this right here. Now keep in mind we can find the hypotenuse. Hopefully by now you see that this is a 3, 4, 5 triangle. So this right here is going to be 5, and I lost my pen. Here is 5. A lot of students ask why this 5 is positive. Well, keep in mind, if you were to do the Pythagorean theorem, you can see that this right here, negative 3 squared, would have gave me 9, and 4 squared, negative 4 squared would have given me 16. Still, when you square it, those negatives would go ahead and become positives. Okay, so right here we can go ahead and see that theta is the angle formed right here between the adjacent and the hypotenuse. And we can see that they want us to find cosine of this given theta, which we can see is the adjacent side is negative 3 over the hypotenuse, which is 5. For my sine of this angle that I do not know of, it's going to be the opposite length, which is negative 4 over its hypotenuse, which is 5. So hopefully that's not that bad. If it is, just I encourage you to do more practice problems or rewatch the video or just ask me for help. Okay, the week at a glance for my live students. Okay, and today we'll be learning how to find, how to evaluate these trig functions given reference angles. Okay, so this right here is what I call the trig bow tie. Keep in mind we are talking about the angles being in here, and these triangles, and hopefully you can see them, they are with the orientation of where they would be. Like keep in mind this triangle would be our quadrant 1, this would be quadrant 2, quadrant 3. Notice how it is still with the horizontal, and the triangle forms the opposite side that touches its the x-axis, right? X-axis. So very, very important. I think that's the only part that will, if anything, mess us up. I went ahead and labeled everything as in all students take calculus. Okay, so from here, what I want you to know, So sorry, blanked out. So go ahead and pause the video and write this down. Okay, this should be from your notes from yesterday as well, if anything. It doesn't hurt to write them again. Okay, awesome. So let's go ahead and continue. The next part of notes that I want you to know is reference angle. What the heck is a reference angle? What does it mean? Well, what I'm talking about a reference angle is pretty much the angle, right, that is necessary for your angle. Well, let me just say there you're gonna be given a theta. That theta is most likely going to be over 180 or less than 180, or um, less than 360, or well, pretty much. Sorry, I blanked out again. Pretty much what I'm saying is that you're looking for this little angle that will go ahead and be needed to make 180 or make 360. That is what I mean by a reference angle. So I have these right here to show you how this would look like in quadrant one. I'm sorry, quadrant 2, 3, and 4. Um, so let's go ahead and try one. Let's go ahead and see how this will look like for 120 degrees. So we have this angle right here, and I'm going to say 120 degrees. I know it is bigger than 90, right? But it is not bigger than 180. So it should be something like this in quadrant 2. This right here would be 120 degrees. Now, what I want you to know is that the reference angle is the angle that exists right there. So my question to you is 180 minus 120 will give us indeed the reference angle, which in this case, hopefully you see that is 60 degrees. So my reference angle, that is horrible, my reference angle is 60 degrees, or also known as pi over 3. Okay, that's pretty much what I'm saying. So for the most part, this isn't that bad. And we're going to go ahead and try some that are going to be in the quadrant 3 and quadrant 4. Okay. Alrighty. So go ahead and give these a try. So the easiest way to do this is to go ahead and sketch them. Okay. So 150 degrees, what quadrant would that land in? If you struggled with that, well, keep in mind this is 90, this is 180, this is 270, and this is 360. Okay. So from there, it gives you an idea of where it should land, right? So it's bigger than 90, but less than 180. So 150 lands right here. So from here, we're going to go ahead and see that there is an angle missing from 150 to 180. And that angle, we can go ahead and find it by doing our quick maths, or if you have to, you can go ahead and subtract it, and you can see that this right here would be 30 degrees. So my angle would be 30 degrees. So 30 degrees is my reference angle. You can also say that that is pi over 6. Okay, so that's pretty cool, because this is going to help us find, back to our 30, 60, 90 triangles, and hopefully you can see that, right? That the central angle here would be 30 degrees. Okay. All right, so let's give the next one a try. So we have 0 degrees, 90 degrees, 180, 270, and the a full revolution will be 360. So according to this, right, we start in standard position. It would be all the way around because it's bigger than 270, but it is not bigger than 360. So our triangle here that we're working with would be this one right here. And this right here would be my theta. And my theta in this case would be the difference, right? Because this is 300, would be the difference between 360 and 300. So my theta would be 60 degrees. In this case, pi over 3. That would be the angle from here to here, right? From 300 to 360. Awesome. So those were not that bad. Let's go ahead and give it a try when they are in radians. So I really do see that students struggle more when it is radians. It's just that we didn't have enough practice with sketching them to begin with. Okay, but overall, this concept is not that hard. I do have a lot of students that prefer to convert this to a degree, so they get 2 pi over 3. You could definitely do that. I won't get after you, but I just want to let you know that it does take more time, and you're not kind of embracing the new idea. So if you are already seeing this and you're like, how do I sketch this? I would prefer that you pause the video and go watch that one and then come back to this one. Okay, I'll try to re-explain it, but you should know something like this, right? So ideally what I'm doing here is I'm getting my pi and I'm gonna slice it into 3 equal sections, right? So like so, where this right here will be your pi over 3, this right here is your 2 pi over 3, and half a circle will be 3 pi over 3. Okay, from here, what I want is the angle created from here to here is 2 pi over 3. I want the reference angle, right? The reference angle is the angle that is missing in order for me to be at pi. So keep in mind, I'm at 2 pi over 3. Half a circle, half a revolution will be 3 pi over 3. So hopefully you can see it like the same way you would see a pizza. How many slices would you need for it to be the top half of the pizza, you know? If you are not seeing that, you can go ahead and just do subtractions the same way we did for the other one, the other degree ones. And you can see that the difference right here will be a pi over 3. So that's my reference angle, pi over 3, which is 60 degrees. Okay, so let's go ahead and try the next one. 5 pi over 6. This one's a little tougher, but it's still the same idea. In this case, I'm going to go ahead and get my top side of the pizza, and I'm going to divide it into 6 equal sections. So let me go ahead and do that. So here I would have 1 slice. Here I would have 2 slices. On 90 degrees, I would have a 3rd slice, 4th slice, 5th slice, and on the pi, I would have another slice. Okay. So ideally, each slice is a pi over 6. So now I have 2 pi's over 6, right? 2 slices out of 6. 3 pi over 6. 4 pi over 6. Okay. 5 pi over 6. That's the right 7. And 6 slices out of 6. Okay. So we have all of this right here. So we have, let me get a marker. We have that the angle that we were given was this right here. 5 pi over 6. 5 pi over 6. But keep in mind, what I'm going to go ahead and find is this little theta on the other side. So hopefully you're able to see that the reference angle right here would be that pi over 6, right? Because this area right here, all that is missing is just 1 slice, and we know each slice is a pi over 6. Is my reference angle. Or we can say that that is 30 degrees if you chose that route. They're the same thing. Okay, so by now you're probably thinking, well, what the heck? How am I going to go ahead and solve something like this? What would I need this for? Well, consider the fact that you might have sine of 300. Let's go ahead and look at that. If you have sine of 300, you're going to do the exact same thing. So we saw this in the last example. We saw that this 0, this is 90, this is 180, this is 360. Sorry, not 360, 270. And this right here is 360. So ideally, my 300 degrees is this part right here, right? This is 300 degrees. And my reference angle, I'll draw that in red. My reference angle is this angle right here. This is 60 degrees. Okay. So ideally, I am working, according to the bow tie, I am working with this right here, this triangle right here. Okay. So we have this right here, and we can find out that this is my right angle created at this intersection, and we have 30 degrees right here. Now keep in mind, guys, it doesn't have to be in degrees, it can also be in radians, which is this is pi over 3, 30 degrees is pi over 6, and 90 degrees is pi over 2. Okay, so from here, we can go ahead and fill in this triangle, because keep in mind this is a 30, 60, 90, right? 30, 60, 90. 30, 60, 90. This is 2, the square root of 3, and this is 1. These are from the notes from yesterday. Okay, now keep in mind, some of this stuff will be reflected, it will be switched over just keep in mind of the signs, okay? So 60 degrees, according to my 30, 60, 90 triangle, is square root of 3. So let's look at that. It is below the x-axis, so therefore this must be a negative square root of 3. How about the angle, the length created by 60 degrees? So hopefully you're able to see that this right here is 1, and my 90 gave me my 2. A lot of students like to look at this too, and they're like, shouldn't that be negative? Well, it is below the x-axis. I agree with you there, but keep in mind how we figured out the radius, the distance of the radius. We squared it, right? In the Pythagorean theorem, we squared it. It's a squared plus b squared equals c squared. So that negative sign essentially turns positive with the multiplication of itself. Okay, so we're going to go ahead and see that the radius is positive. The hypotenuse is positive. Okay, so this right here on the x-axis is my adjacent. My opposite is my negative square root of 3, and my hypotenuse is this what I call the radius, right? Because we're in the unit circle, right? Okay, from here, we need to go ahead and find sine of 300 degrees, which we don't know, but we do know that if I just look at quadrant 4, I can use the reference angle. Let me not say equal to. I'm going to say is the reference angle at a 60 degrees. So it will give me the same answer, and that's what I'm going to go ahead and do it. Because it is the same, it will be essentially the same thing, except that I'm not doing it for 300, I'm doing it for 60. So sine is opposite over my hypotenuse. So it's going to be sine of 300 is going to be equal to the opposite, which is negative square root of 3, divided by my hypotenuse, which is 2. So the sine of 300 is the proportion of negative square root of 3 over 2. Okay. Let's jump back to radians. So I want you to go ahead and sketch it first. Okay, so now that you've sketched it, we get to see that this angle is going to go ahead and land. Well, let's split it up. This is one slice. We want 4 slices out of the pizza being divided equally into sections of 3. Right, so we should have a pi over 3, then another pi over 3, that's 2 pi. Then a third one is a complete horizontal, and then a fourth one out of 3. Right, because it's telling us to divide it equally into 3 sections. So we have all of this. So ideally, I am working in with something like this. And I'm going to go ahead and see that my reference angle is going to be this theta right here. Okay, so I'm working with this triangle right here. Let me go ahead and make stuff a little bigger. And I can see that my reference angle from 3 pi over 4, to 4 pi over 4 is just a pi over 3, sorry. So from 3 pi over 3 all the way to 4 pi over 3 is just a section of 1 pi over 3, one of these right here. So we know pi over 3 is going to be 60 degrees, right? So I'm going to go ahead and get this right here, and I'm going to try to zoom it in over here. So it should have something like that, right? So it's going to make it bigger. Okay. So we know pi over 3 is 60. So therefore, this right here is 30, and this right here is 90. So from here, keep in mind I just zoomed that picture in. Right. We can go ahead and fill this in. So the length projected by this angle pi over 3 is square root of 3. Keep in mind it is below, so it must be negative. The length projected by the angle of 30 is 1, but keep in mind it is on the left-hand side, so it's negative, and then 90 gave me a 2. Keep in mind, because of the Pythagorean theorem, this 2 is positive. Okay, so let's go ahead and continue. They want us to find the cosine of 4 pi over 3, which we can go ahead and see that will give me adjacent over my hypotenuse, which is -1 over 2, -1/2, because we use the reference angle of pi over 3. So that is very messy. Okay. So we're going to go ahead and see the following. we have cosine of 3 pi over 4, and we're doing the exact same thing. So go ahead and sketch it and find out where does the terminal side end. So hopefully you see that we're splitting this pi, right, this pi, which is 180 degrees, into 4 equal sections. So here would be 1, here would be 2, here's my third one, here's my fourth one, where each one is a pi over 4, which is 45 degrees, right? So we can go ahead and see that I want 3 of these sections. Here's one, here's my second, 2 pi over 4, which is the same thing as 90, and then 3 pi over 4. So we're going to go ahead and work with this right here. Okay. Now, I don't want you to get frightened, spooky scared, because of the 45s. Keep in mind the 45 triangle. In our notes, we saw that it was pi over 4, which projects a length of 1. So this right here on the top, this right here is a 90, so that's 2, stays the same. And this right, square root of 2. And then this is another 45, which projects a 1. However, this 1 right here is to the left. So the left of 0, which is negative on the horizontal. Okay, from here, they want us to find the cosine. So we want to find the cosine of 3 pi over 4. And we can find that if we find the cosine of pi over 4, pi over 4 on quadrant 2 by using the reference angles. So cosine is my adjacent side over my hypotenuse, which is going to be -1 divided by my hypotenuse square root of 2. Keep in mind, I cannot have a square root in the denominator. Sorry guys, it's Thursday. So I'm going to multiply by square root of 2 on the numerator and denominator. So we have a negative square root of 2 on the top, and square root of 2 times square root of 2 is just 2. So this should be your solution. Okay. What I want you to do next, guys, is go ahead and go practice some of these on your own. So I went ahead and made you guys a quick assignment that is posted on Teams. So go ahead and give that a try, and hopefully you enjoyed this lesson. If you still do have questions, please message me, email me, or just put a question in the chat box. In the comments, and I'll gladly reach back to you as fast as I can. Okay. As always, guys, it was a pleasure, and thank you.